Good morning everyone. I am B. Soria and I'll be presenting today on Navigating the Android Landscape, a technical deep dive into SDK and API levels. Android's open and adaptive ecosystem gives the developers tremendous freedom, but with that freedom comes complexity. Understanding the role of SDKs and API levels is fundamental for building robust, compatible, and secure Android applications. Over the next several minutes, we will examine how these layers work together, discuss version management strategies, and understand how careful configurations can optimize both performance and market reach. Let us begin by clarifying two essential but often misunderstood components: the software development kit (SDK) and the application programming interface (API). The Android application is a comprehensive suite of tools provided by Google. It includes compilers, build utilities, debuggers, emulators, libraries, and documentation. Essentially, the full environment is required to design, build, and test an Android application. Meanwhile, the API defines how the applications interact with the operating system. It's a collection of system calls, classes, and methods that provide access to the Android framework's underlying capabilities. In very simple terms, the SDK provides the resources for development, while the API defines the rules of engagements with the system. Together, they form the backbone of the Android app development. The SDK is not a single entity, but a collection of integrated components that collectively support every stage of development lifecycle. The build tools and compilers convert the source code into text bytecode and package it as APK or API files ready for distribution. The SDK libraries provide pre-built functionalities that simplify UI creation, network communication, and hardware access. The emulator and system images allow developers to simulate and real devices and test apps across different configurations without needing physical hardware. The documentation and samples offer detailed technical guidance and reference implementations for best practicals. The SDK manager within the Android Studio serves as the central point for downloading, updating, managing the SDK components corresponding to specific Android versions and API levels. Every Android release is associated with a unique API level. For example, Android 13 corresponds to API level 33. These API levels are critical markers of platform evolution and compatibility. They determine what features are available and how applications will behave on different versions of the OS. API levels influence three major areas: versioning and features, compatibility, and security compliance. In versioning and features, each API level introduces new capabilities and performance improvements. Compiling against a higher API level allows the developer to utilize new features. Meanwhile, in compatibility, the Android guarantees that apps built for one API level will continue to function on later levels. This ensures forward compatibility, although behavioral changes may occur. In security compliance, the Google Play mandates minimum and target API levels to ensure applications follow modern security and privacy practices. Thus, API levels serve as the architectural handshake between developers and the Android operating system. Within the Android manifest, two attributes define your application's operational scope and behavior: the minimum SDK version and the target SDK version. The minimum SDK version indicates the lowest API level your app supports. Devices running older versions of this value cannot install the app. This prevents runtime failures due to missing features. The target SDK version specifies the version of your app which has been built and tested against. Targeting newer SDKs signals compliance with the latest Android policies and behaviors, which includes modern permission handling, background execution limits, and storage access restrictions. These two parameters, when set strategically, allows developers to balance market reach with technical advancement. A lower minimum SDK expands accessibility, while higher SDK targets and ensures optimal performance and adherence to evolving security standards. Now, let's talk about one of the rarely used Max SDK version. The Max SDK version attribute, though available, is rarely used in modern Android development. It sets an upper limit, preventing installations on devices with API levels higher than the specified value. However, this restricts forward compatibility and can cause the apps to disappear from the Play Store for users on updated Android versions. Google discusses this attribute, except as a temporary safeguard against severe platform-specific bugs. Instead of imposing version limits, developers are encouraged to use Android X libraries and runtime checks. These approaches maintain long-term adaptability and ensure that applications remain compatible with future releases. Now, let's consider a practical example, which is implementing biometric authentication. The Biometric Prompt API was introduced in the API level 28 to provide a unified and secure method for user authentication. However, many devices still operate on lower versions. A developer can manage this gracefully through version checks such as this following code given here, in which we specify the build version and check on it. So we can prevent older devices which does not support the following biometric authentication can avoid it. This conditional approach allows modern devices to benefit from the advanced features while ensuring older ones can still retain fallback methods like PIN or password authentication. As you can see in the code, if the biometric feature is not available, we can proceed with the else statement here, which shows the show password prompt, which in return returns the entrusts the user to type the password instead of the biometric authentication. It's an elegant example of adaptive design, which maintains consistency, inclusivity, and a security across fragmented ecosystem. Now, let's look into some advantages and challenges. Managing SDK and API levels is both strategic and technical balancing act. It directly affects application performance, compatibility, and maintenance cost. Some of the advantages include enhanced security, as targeting newer SDKs enforces stricter permissions and privacy frameworks. The access to innovative features such as foldable device APIs, refined battery optimization, and advanced camera capabilities further enhance the capabilities of the phone. So, wider user reach by supporting a broader range of devices through a lower minimum SDK configuration. Now let's look into the challenges. Some of the challenges include fragmentation, depreciation, mandatory policy updates, and effective API management. So, in fragmentation, supporting multiple Android versions increases the testing and code management effort, whereas in depreciation, the APIs often evolve or become obsolete, demanding frequent updates. Mandatory policy updates in Google Play required periodic upgrades to target SDK version to maintain store eligibility. The effective API management ensures a balance between leveraging innovation and sustaining stability across releases. To conclude the technical analysis, let's consolidate the core strategies for effective SDK and API management. First, define the reach. Select your minimum SDK version carefully based on the realistic assessment of your target audience and device data distribution. Next, target modern. Always compile against the latest stable API level to stay compliant and benefit from the system enhancements. Next, adopt Android X. Use compatibility libraries to simplify cross-version support and reduce maintenance complexity. And finally, perform comprehensive testing. This is very essential as we combine local emulators, real devices, and cloud platforms such as Firebase Test Lab for validation across environments. Ultimately, the strategic version management minimizes the technical debt, enhances application reliability, and optimizes the development lifecycle of scalability and compliance. So, in the next segment, I will demonstrate the practical implementation within Android Studio, showcasing how SDK tools, version configuration, and API level targeting are applied in a real development environment. Through this demonstration, we'll connect the theoretical principles we've discussed with hands-on execution, illustrating how versioning decisions directly affect the build behavior, compatibility, and deployment outcomes. Thank you. So let's get started. Here we can check the target SDK and minimum SDK. As you can see here, we have the minimum SDK and here we have the target SDK. By customizing this, we can ensure backwards compatibility and security compliances. Thank you.